So a pH curve is just a graph that illustrates the change in pH during the continuous addition of a titrant to a sample. So this is a way of visualizing what happens during a titration and specifically what happens with an acid and a base reacting together, measuring the pH as we go. So we're going to look at a simulation that shows a pH curve being developed. So over here we've got hydrochloric acid in the Erlenmeyer flask, and we are going to be titrating with sodium hydroxide. And in this situation, there is no indicator. So it is the change in pH that's going to indicate that the reaction is complete. So I'm going to start by adding some sodium hydroxide to hydrochloric acid. Well, what happens is at the beginning, if you look at the bottom, we can see that the water, the solvent, is not included in the molecular diagram. And you can see that we've got chloride and we have hydrogen ions. And those are present in solution and represented by the green and the blue circles. When I add sodium hydroxide to hydrochloric acid, let's see what happens at the molecular scale and what happens to the pH. So I'm going to begin the titration, and I'm going to add 5 milliliters of sodium hydroxide at a time. So you can see as we add it in, I've added sodium hydroxide, and the sodium hydroxide was the red and blue. And you can see it picked up the hydrogen ions and formed water. So now we have water in our molecular diagram. But notice what's really affecting the pH is just the presence of hydrogen ion. There is no free hydroxide, so you'll notice the pH in the first 5 milliliters hardly changed at all. If I add 5 milliliters more, same thing. The sodium hydroxide comes in, binds with the blue hydrogen ions, forms water. There's no free hydroxide. The pH curve pH stays pretty much the same. Add another 5 milliliters, same thing. The hydroxide binds the hydrogen ions, forming water. The only thing that's affecting the pH is the free hydrogen ions in solution. pH stays really low. Add another 5 milliliters, same thing. Hydroxide picks up the hydrogen ion, forming water. The only thing affecting the pH are the free hydrogen ions in solution. pH stays the same. Okay, same thing. Pick up some more hydrogen ions. We have just a couple free hydrogen ions, and those are what's dominating the pH, because otherwise everything else in there has no effect on the pH. Okay, add 5 more, look to see what happens. Now, all the hydrogen ions have been picked up. We have sodium ions, we have chloride ions, and we have water molecules. So now we are at a point where it is completely neutral. We call this the end point of the reaction. If there was an indicator, you would have seen it by a color change. On the pH curve, you'll notice it is halfway up the vertical region. You can only see the half now, but you're going to see the rest of it right away. If it's a strong acid and a strong base reacting, the end point will be at a pH of 7. So let's continue to add sodium hydroxide. As the hydroxide ions are being added, they are now dominating the pH. So you can see the rest of that vertical region of the graph has increased. And if I was to add 5 more milliliters sodium hydroxide, the excess hydroxide now is dominating the pH, and we're going to see that level off. So this animation is showing us the end point of the reaction when the moles of acid equal the moles of the base, and that's right here at the center mark. Okay, and we can use the values from the pH curve to do some stoichiometry right now, because in here we have all the information we need to find the moles of given. Okay, our moles of given is coming from concentration and volume. We are given the concentration, that's molarity, 0.2 moles per liter of sodium hydroxide. We know the volume for the end point. From where the middle was, we drop it down to get 30 milliliters of sodium hydroxide, so we can find moles of given. Our mole ratio is 1:1 for this titration. And then I can find my concentration of our acid. Because I have our volume, concentration is moles over volume, and then I could work out what the concentration would be. So pH curves give us an indication of how we can complete our stoichiometry, and the next podcast will demonstrate the stoichiometry.